In some ways, raster overlay analysis is more straightforward than vector overlay analysis, assuming things are set up that way. In this example here, we can see one raster layer, which is being combined with another raster layer in order to produce the output raster layer at the bottom. And the thing that makes this work so easily is that each of these grid cells is the same size as each of these grid cells, is the same size as the output grid cell, and they're all lined up right on top of each other. So in this case, it works pretty simply. We might have two layers, layer A and layer B here. One might have attribute types A and B, which are related to some soil name, and the other one might have some sort of ID, which is related to a land use. Each grid cell is going to have one value, and when they combine, a new grid is going to come out. Same number of grid cells, same location, but each of those grid cells is going to be linked to both of those values. So in this case, for example, 1A would be forest and everwood loam type soil, and we can see that that all of those are just going to, each grid cell is just going to have one of those combined values, and we'll be able to get back to those values. However, if our grids don't perfectly line up, or if they're different sizes, then we have to make some adjustments. In this case here, we have layer 1 that we'd like to combine with layer 2, but layer 2 has smaller grid cells, and also the grid cells are not aligned geographically. They're tilted when compared to the other layer here. So what we then have to do for each cell, like cell A there, is we have to reclassify or give a new value to layer 2 and basically build a new grid there. The values that we start out with layer 2, we might be taking, in this example here, we have 4 grid cells, 4 full grid cells, or 4 mostly full grid cells inside, and then some partial grid cells. We might be just taking the value of the grid cell that's closest to the center of this new cell A, which might be this one here, or we might be taking an average of these. We might be weighting the average by how much of a grid cell is within, an old grid cell is within the new grid cell, and we can be calculating that in all those ways. But essentially, we're just trying to get to a point where, once again, these two grids line up perfectly, they have the same size grid cells in the same orientation, and then we can do our raster overlay analysis. One common type of raster overlay analysis that we do is to reclassify our data. So, of course, when we put a raster on a map, we can assign any colors we want to any values. But sometimes we actually want to break these into categories so that all of a range of values will be reassigned to a single value. So in this example here, when we go from 10 to 12 and 12 to 14 and 14 to 16, all the way up to 80 inches of precipitation, we might just want to break this into a category of 10 to 20. And then all 1, 2, 3, 4, 5 of these values will be recategorized into one value, which will represent 10 to 20. So in this way, we're kind of like reducing our data. We're eliminating some of the detail. It's kind of like classifying the data, but once again, we're outputting a new raster layer that we didn't have before once we go through the reclassify command.